Okay, good afternoon, everybody. My name's Andy Stevenson. I'm the chair of the North East region of the IMechE, and I'm delighted to welcome you to our third professional development session today. So we're going to be talking about career learning assessment. We've got two speakers, Denis Healy and Daniel Cunny, who's a chartered engineer at SMD. He's going to talk a little bit about his experience going through the career learning assessment approach. For those of you who haven't been in one of these sessions before, they are recorded and you can find them at the IMechE's YouTube channel. For those that are interested, our next technical talk is going to be on decarbonisation of railway transport. That's on the 17th of November, and you can find that via the IMechE's Near You page, and you can register for that. Coming up, we're hoping to have another PDP session on mentor training for the Monitored Professional Development Scheme. The date for that's to be confirmed, so that'll either be in December or early January, and that'll be alongside our next technical talk as well. So look out for details on the Near You website or on the emails that will be sent to you. Just as a reminder, some of the future topics that we've got lined up to continue our kind of series in PDP talks. We've got one on getting professional registered in January, how to become an IMechE fellow in February, CPD in March, and then some essentials for early year graduates in April. So I will now hand you across to Denis Healy, who's going to go through the IMechE's presentation, talking through the career learning assessment approach. Over to you, Denis.
Thank you very much for that, Andy, and welcome everybody. This is all about well, two things really. It's intriguingly entitled "How to Become CEng or IENG Using Your Career Learning Instead of a Degree," and that really opens up this subject of what's called career learning assessment. But I want to link this to this subject of further learning, because sometimes it's a bit of a thorny issue. How do I actually, what do we mean by further learning? What does the IMechE want? What does it expect? And I want to sort of take both these subjects together. Now, I'm delighted that Dan Cunny is with us today. Dan is an engineer in SMD. He'll introduce himself shortly and say a little bit about his company. But the reason I've asked Dan to come along is because Dan was one of the very first engineers to go through this career learning assessment process quite a few years ago now. And the process is still, slightly different, but to all intents and purposes, it's the same. And Dan's going to sort of talk a little bit about his experience, because to be absolutely honest, there's nothing like hearing it from somebody who's actually done it. So I'm delighted that he's come along. And what we'll do is, I think there's a chat function. You can ask questions. Andy's going to monitor the chat, and we'll read any questions out, as they come along. But what I want to do first of all is to sort of look at this whole qualifications bit first of all, and that is where we're focusing today. So we're not talking today about the actual competence requirements. We're not talking about completing the CEng application form. We're talking about learning. We're talking about academics, and we're talking about how you demonstrate underpinning academic knowledge. So a bit of a refresher, and probably some of you are familiar with this anyway. The academic requirement since 1999 for chartered status is master's level. So typically, if you have an accredited MEng, which is a first degree, you meet the academic requirement for chartered status. And if you have an accredited bachelor's degree since 1999, you meet the academic requirement for incorporated engineer. And if you have any of the qualifications on the left, below degree level, but you're sort of talking there about NVQ qualifications, HNC, HND, BTEC, City and Guilds, those all meet the academic requirement for engineering technician, and those, of course, are the 3 levels of professional registration. Now, if you are a bachelor's level graduate since 1999 and you wish to get chartered, then you would need to demonstrate some further learning to master's level. So that puts you into the bottom right-hand green box there. And similarly, if you had, say, a degree, a qualification below degree level, one of the left-hand IMechE qualifications, and you wanted to get IENG, then you would need to demonstrate some further learning to bachelor's level. So that's the principle of the Engineering Council's requirements for academic requirements. But the very important point is that statement at the bottom there. Experience can count in lieu of qualifications. Now, what's important to remember here is the Engineering Council, who of course set the standard, who produce the UK spec, who set the framework, and who decide the academic requirements, they don't say you have to have a master's degree to be chartered, and they don't say you have to have a bachelor's degree to be incorporated. What they say is you have to have master's level knowledge and understanding, or you have to have bachelor's level knowledge and understanding. And so it's a bit subtle. Most engineers would demonstrate their knowledge and understanding to master's or bachelor's level through the academic route. So they will have a degree, basically a master's degree or a bachelor's degree. But what it recognises is that it's possible to have master's level knowledge and understanding without necessarily acquiring that knowledge in the formal academic setting. So, if you're experienced, if you're a mid-career engineer, you may very well be in a position where you've learnt these things. You maybe didn't learn them in a lecture theatre, but you understand the principles, the mechanical principles behind thermodynamics and stress analysis and finite element analysis. You understand Boyle's law. You understand the principles behind heat transfer calculations because you've learned them on the job, perhaps at the University of Life rather than a formal university in an academic setting. And so the Engineering Council say, if you're in that position, then you might be able to demonstrate that learning. And because you've acquired it through your experiential learning or your career learning. And that really is where career learning assessment comes in. It's an engineer saying, I don't have a formal master's degree. I might have a bachelor's degree for example, but I don't have a master's degree, but I believe I have got master's level knowledge and understanding. And career learning assessment is the opportunity to demonstrate that. So that's what we're going to be exploring today. So this academic benchmark applies to qualifications completed from 1999 onwards. And that does raise the question, which I want to deal with now, about what happened before then. And before we had UK spec, we had predecessor sort of frameworks, SARTOR 2 and SARTOR 3. And this changed in 1999. That's quite a sort of key date, and many of you will probably be aware of that already. When I first joined IMechE, that wasn't very long ago, but it seems that it's disappearing into the dim and distant past. But the bottom line was that they changed it then. Up until then, if you had a bachelor's degree, such as a BEng or a BSc or something of that kind, it met the academic requirement for chartered status. And also some of the older HND qualifications met the academic requirement for incorporated engineer. And the point really is that if it met the academic requirements then it still does. So we do find engineers, and if any of you have got a bachelor's degree that you started before September 1999, it is possible that your degree might be meeting the academic requirement and accredited for CEng, or indeed it might be accredited for IENG if it's an HND. So I suppose I'm speaking in fairly general terms there, and every case is different. So a very important thing is to check, first of all, because you need to check out your own circumstances and your own qualifications. So this qualification checker is quite important, and that link there, IMechE.org/qualification checker, is well worth noting. It's a very simple form. You put on it where you went, what you got, when you went there, what it says on your degree certificate, and you submit it to the IMechE. And usually within a few days, perhaps a week or so, it's taking a bit longer at the moment due to the circumstances that we find ourselves in, you will receive an email which will confirm the status of your degree and what it's accredited for. And you'll probably find that it says one of three things. You'll probably find either, first of all, it will say you are accredited for a chartered engineer. So if you've got an IMechE, or you've done further learning because you've got a first degree and a master, an MSc, for example, or if you've got one of those older bachelor's degrees from before 1999, that's what it will say. If you've got a bachelor's degree post 1999, it may well say your degree is accredited for IENG, and if you want to do CEng, you will need to do further learning. Or it might say your degree is not accredited, you will need to do academic review. Now, if it says you need to do academic review, that's not a problem. Many people have to do academic review because their degrees are not accredited. Now, if your degree is not accredited, it's not a problem. IMechE only generally accredits mechanical-based degrees, mainly from UK universities. But lots of engineers have got other degrees that are not necessarily ones that IMechE have accredited. So, for example, it might have been accredited by another institution, or it might be a STEM degree in a different discipline. It could be a maths or physics or that kind of degree. Or it could be an overseas degree. That's not accredited, not because these degrees are different. They're all broadly similar. It's simply because IMechE logistically can't go and accredit every degree in the world, because that would obviously involve a lot of cost and a lot of logistical difficulty. So what we do is when somebody presents a degree that isn't accredited, we have this process called academic review, which deals with that. And you submit your degree through the academic review process, and it's all online. You'll find it at IMechE.org/academic review, all one word. And the qualification checker will tell you whether you have to do this or not. And if you do have to do it, it's not a problem. It's just going to add a few weeks to your to the process. Because what you do is you upload your degree certificate from your first degree. You upload your qualifications subsequent to that. So you might have a master's, MSc or something. Or you might have a PhD, you might have to load some transcripts or something like that. And it's all based on the first degree. Now, so I mean, even if you've got something, I had a person this morning I was speaking to who had a first degree, which wasn't accredited. It was an overseas degree, but he had a PhD from the UK. He didn't have a master's degree. He would still have to do academic review because his first degree was not accredited. But in that kind of case, it's a formality. So most of the time, academic review is a formality, especially where you've got a master's qualification or a PhD or something like that. But you may have the slight inconvenience of having to do it. It takes about 10 weeks to get the outcome of academic review. That's what we tend to say normally, maybe 10 to 12 at this time because things have slowed down a little bit. But it's not a showstopper in any way. It's just something that you have to do if you need to do it. So that's academic review. And of course, the other option is career learning assessment, which is what I'm going to be talking about in a bit more detail. But what I want to try and differentiate at this point is the difference between further learning and career learning assessment. Now, if you are a developing engineer and you've got a bachelor's degree, you'll need to complete what we call formal further learning to master's level, because career learning assessment only gets offered to people who can demonstrate experiential learning. And experiential learning, by definition, can only happen to people who've got experience. And 3 or 4 years is not sufficient experience. So if you're a graduate and you are working towards CEng, you might be doing MPDS or whatever, that's all related to your competence. It's not related to your learning. So if you're doing a monitor professional development scheme and you're a bachelor's level graduate, the MPDS is not going to turn you from a bachelor's level graduate into a master's level graduate. You have to do formal further learning, which I'm going to talk about in a minute as to what exactly that is. But if you are more experienced, if you're a mid-career engineer, and then you might, and notice I've underlined the word might, made it red, because that's a very important word. You might be able to demonstrate that you've reached master's level for CEng through your experiential learning. Now, the operative word is might, because you might not. That's the corollary to that. So the first thing is, well, how do we sort of determine who might and who might not? So we kind of take a general sort of view that in order to be offered career learning assessment, you probably need upwards of 7 years postgraduate experience, and anything less than that, you're probably not going to be in the right ballpark. Obviously, there's going to be a sort of cusp, I suppose. I mean, if you're a developing engineer with 4 years experience, that's not enough. Perhaps when you're reaching 6 years or something, you might think it's more likely. So what the IMechE generally says is, if you've got upwards of 7 years, roughly, then you think you can probably make the case for demonstrating that you've got career learning experience to master's level. But it doesn't mean, and this is the problem, that it doesn't mean that somebody with 7 years plus postgraduate experience is therefore at master's level. And sometimes we do come across engineers who sort of say, well, look, I'm okay to get chartered, aren't I? I can do a CLA because I've got 10 years experience since I graduated. Well, yeah, you've got 10 years experience since you graduated, but experience, it's not about experience, it's about master's level learning. So can you do thermodynamics to master's level? Do you understand the principles of the heat calculations and the stress analysis calculations? And have you done the important academic principles that you've not necessarily learned at uni, but have you done them? Just because you've done 10 years experience doesn't mean you've done them, but you might have done them. And that's why career learning assessment is something that's important to people. I suppose in a way it's a retrospective look at further learning. So further learning is something that you've got to do in the future because you've not done it yet. Career learning assessment is, well, you might have already done your further learning, and career learning assessment is your opportunity to demonstrate that you've done it. So that's where career learning, what career learning is essentially about. So I want to, before we get into career learning assessment, which is the experiential learning bit, I want to just deal with this formal further learning. So this is the bit that's relevant for developing engineers rather than mid-career engineers. What is further learning? Well, it's the knowledge gained which underpins competence. The two things are separate, okay? You've got to develop your competence, which we're not talking about today, and alongside that, you're going to have further learning. And one of the ways that you do further learning is through what's called a further learning plan. Now, I suppose there are two ways in which you can do further learning. Usually, one of these two. So one is an accredited MSc. So you've got a bachelor's degree. You might go and do an accredited MSc, a full MSc, 2-year part-time MSc, possibly 8 modules, whatever it is, and that's going to give you master's level. That's further learning. But the other way is this individual further learning plan. And with an individual further learning plan is your proposal for further learning. It's what is it that you're going to do. So sometimes people come to me and say, what do I need to do for my further learning? And the answer to that is, I don't know. You tell me. It's your learning. What do you want to do? And the idea is that the developing engineer proposes a plan. And the idea is that they get that plan signed off before they start doing it, because nobody wants to start working on a further learning program unless it's going to work, unless it's going to be acceptable to the IMechE. So if you do a further learning plan, there are 2 bits to the further learning plan, right? The first bit is called engineering and science deepening, right? And this is really a key part, because this is where you're going to be doing the technical stuff, the deepening. And this is usually university modules. And on this bit, you have to put down some modules that you want to do, that you fancy doing, right? Now, how many do you put down? Well, this is an alternative to doing a full MSc. So in a full MSc, you might be doing 8 modules. With this one, you perhaps select 2 or 3 modules, no more than that. And you make up for the fact that you're only doing 2 or 3 and not 8 by doing some work-based learning proposals. And the work-based learning proposals are the second requirement of a further learning plan. And this comes under this heading of technical and non-technical broadening. Okay, so you've got engineering and science deepening, which is university modules typically. And then you've got technical and non-technical broadening. And that is usually work-based learning. And so if you're working as a developing engineer and you've got your mentor, you would agree with them what activities you're going to be doing. You might be seconded to a certain part of the business, and you will be proposing some elements of work. And for both these science deepening, engineering deepening, and the broadening, what you have to do is you have to put down what it is that you want to do, and then you have to put down the learning outcomes. So what is it you're going to learn? So with the university modules, it's usually fairly straightforward because all the learning outcomes are written down on the prospectus. With the broadening, you'll put it down. What are the learning outcomes? So I'm going to be seconded to such and such a department for the next 3 months, and it's going to be giving me advanced knowledge and understanding of vibration, or heat transfer, or stress analysis, or thermodynamics, whatever it might be that you are going to learn. And that's signed off by your mentor, okay? And you put these down, basically. You might have 4 or so work-based projects. Some of them might be non-technical, so there's some examples there: cost optimization, cost and quality management, make or buy decisions. I mean, that's the non-technical bit. You just put these down on the further learning plan. Now, you can find lots more information about this at imechE.org/furtherlearning, all one word. And what you'll find in there are some example further learning plans. So you can see exactly what it is that you are supposed to put. And what happens is when you've done it, you submit it to the IMechE, and the academic assessment committee look at this and say, right, is that sufficient? Is that sufficient? And if they think it is sufficient, then they will sign it off. And all you have to do then is complete it. And at the end of it, you have a little sit down with your, actually you've got the examinations usually for the university. So the assessment is usually carried out by the university if it's the examination. The work-based learning bit is usually done by the mentor. So you sit down with your mentor and write a little report on what it is that you've done in your further learning plan, and the mentor will then sign it off. And that then meets the requirement, because so you know before you start that you've met the requirement. And if for any reason what you've put in doesn't meet the requirement, it's not a question of, you failed. It's a question of, well, actually, we'd like you to put something else in. So they might suggest to you what's missing, okay? And so they might say, we want you to put 3 modules in instead of 2 or whatever. Should it be 2 or 3 modules? It really depends on the teaching load that's in there. Universities often run this thing called CATS points, CATS, which is always it doesn't ever seem to be consistent wherever you go. And each course is given a different number of points depending on how many teaching hours there are. And I think some of them have like 100 points for it's based on the number of hours, and some modules will be 100 points, some might be 150. So you need 2 or 3 really, but the IMechE will make a decision on what you've kind of proposed as to whether that will work or not. And then you can go and do that course then, safe in the knowledge that your further learning plan has been signed off. So that is the further learning element. And we would always say, on the further learning plan, we show how the assessment's been carried out. As I've mentioned, universities will usually be doing by examination. And remember that further learning, if you need to do it, is in addition to the usual work-based activities, which is professional development. So it's in addition to the NPDS. So that takes care of further learning, and I hope you'll find on the website, the information about that. Let's put that to one side now and talk about mid-career people. So engineers typically with 7 years plus experience. And the first thing to say, and many people have said this to me, I can't find any information about CLA on the website. You won't find it on the website. And that's because IMechE doesn't want you to do it without you understanding what's involved in it. And that's why my colleagues and I, we make presentations like this all the time, explaining to people what CLA really is. And we define it in this way as a process to demonstrate the required master's or bachelor's level of knowledge of understanding required for CEng or IENG in lieu of holding the appropriate qualifications. And that CLA is not a way of bypassing the academic requirement. Now, the problem is that sometimes people think that it is a way of bypassing the academic requirement. I'll just do CLA. I've got to do CLA first to tell them about what my experience is. No, CLA is not about telling us what your experience is. It's about telling us what your learning is, okay? And far too many people are kind of making the mistake of confusing experience, which is competence, really, and learning. So we do like people to sort of go through this presentation so that we can explain to them exactly what it is. And if you're eligible for it, we'll confirm that and then send you the documentation. Now, it is a two-stage process. I think when Dan, you did it, it was probably a one-stage process, but it was made a two-stage process because we really wanted people to kind of understand that this is about learning. And when you see the form in a minute, I think you'll understand what I mean when I say that we've tried to spell that out a little bit more. So there's like an eligibility stage, which is stage one, and then there's the more detailed submission, which comes subsequently. Now, I think it's important to say, you know, this is instead of a university master's degree or bachelor's degree. So it's not something that you can, you know, write on the back of an envelope or whatever. There is thought that needs to go into it. There's thinking that needs to go into it. And this is harder than filling in a CEng competence application. In other words, the easy bit is later on. If you're in the position where you have to do CLA because you don't have a master's degree, then we can't make any apologies for the fact that you're asking the IMechE and the Engineering Council to confirm that you are at master's level when you're not a master's level graduate. So therefore, the process is one that takes a bit of thinking about. You're not going to do it in 5 minutes. On the other hand, it's not as lengthy as going to university and spending 2 years doing a part-time degree, and neither is it going to cost you £10,000 a year or whatever it is. It's going to cost you 45 quid to apply, which gets deducted off your application fee when you come to apply for CEng. So it's just important to keep that perspective in mind. And when you're doing it, we say it's really important to make the distinction between competency and learning, which I've been trying to say in the last few minutes. Focus upon what you've learned and not what you've done. Tell us what you know, not what you've done. Remember that, because that's an important thing. So when you come to write your CEng application, you'll be focusing on the projects, right? We always say, there's 5 competencies. Tell us about some projects. Well, you are going to be telling us about projects in this CLA application, but not from the point of view of the projects themselves. We want you to focus on the learning that those projects gave you. So think in terms of engineering subjects. So we've listed a few engineering subjects there. I've been referring to 1 or 2 so far, haven't I? Stress, pressure, materials, thermodynamics, fatigue, friction, vibration, fluid dynamics. You can read the list. Think about those and say, right, okay, what do I know about stress, pressure? Right, now what projects can I use to illustrate my knowledge of stress and pressure? And you'll need to demonstrate a similar level of learning to a typical MEng, if it's masters, or BEng if it's masters. And that's what they're looking for. They're looking for academic knowledge, they're looking for technical knowledge. So a few tips for this. Bearing in mind that it's about matching learning to projects to learning, go and have a look online at the master's levels programs to get a feel for the subjects. And we suggest, you create a list of activities. So put the things that you've done in one column and then put a little line across. Actually start with the line, start with the learning, write down stress of thermodynamics, and then just draw a little arrow and say, right, project X, that helped me understand the principles of thermodynamics. That's the project I'm going to write about. And once you've got this list, it should be clear which areas of engineering learning you've deepened the most. And focus your statements around these learning areas, and never forget all the time you're doing it that it's about learning. Am I telling the assessors what I know or what I've done? Well, yeah, don't tell them what you've done, but you're only telling them what you've done as a means to explaining to them what you know, if that makes sense. And I want to put up a slide with a tip, with a comment from a CLA assessor, because this is really typical of what assessors say. And this is a quote: "The experiences and responsibilities cited in the CLA applications are often very impressive, but they're often focused on professional competence rather than academic style knowledge. Applicants need to reflect on the knowledge of theoretical principles that was behind the work for the project cited and expand on this as appropriate. We want to know about the deep academic knowledge of physical laws and derivation of formula that underlies the calculations and the decisions made at a professional level. And applicants often fail to make the distinction between competence and learning. Many applicants may well have the necessary knowledge and understanding, but their applications don't always bring this out because they are focused on competence, not learning." Now, with that in mind, a few years ago, the IMechE developed a new version of the CLA form to try and really bring this out. And what I'm going to try and do, I've practiced this by the way, is bring up the stage 1 form. So and Emma is our fantastic events person, and she's on hand to possibly come and help me do this. So if you hear her, then you will know that she's helping me. I'm assuming that your screen has gone blank at the moment, and I just would like you to come on, Emma, and just confirm, or somebody on mute, Andy or somebody, that you've got the CLA form on the screen.
Yeah, I can see that, Dennis.
Okay, thank you, Andy. So this is the first part of the CLA process. So this is the eligibility bit, and this is a SMART form, and so that means that you answer one question at a time, and when you've answered a question, another one appears. And what the assessors are looking for, as it says there, they want to see in-depth knowledge and understanding of engineering principles which allow problems at the forefront of technology to be successfully tackled. And this will be master's level for CEng and bachelor's level for IENG. And what you do is you answer one question at a time. And it starts at question 1, which is the sort of contact details. And it's asking you, it's the same form for both CEng and IENG. So you tick which one you want to go for. And then what is your highest academic qualification? All of that's fairly straightforward. So you've got a bachelor's degree in engineering subject, that's what you tick. And you put your graduation year on there as well. And how long have you been practicing as an engineer? So that's the sort of background. Now, the form tries to explain to you what we mean by learning. In the past, we didn't have this form and people just didn't get it. So we want to ask you a direct question. Which statement best describes your knowledge and understanding of scientific principles and methodologies, such as the theory of the conservation of energy or the laws of motion? Now, there's 5 statements that you can choose from, ranging from the ridiculous to the sublime, I suppose. And if you click on these information boxes here, where it says more, they should, in theory, come up with some explanations. So the first one, the easy one, I'm aware. So you're aware of the scientific principles and methodologies, but that's all. You're aware of these laws, but you've never used them. And you've never used them. You're not able to derive any scientific methodologies. Well, if you tick that box, then you're not going to be at master's level if you're just aware of laws and theories, but you've never used them. So you might quickly dismiss that one and go to the next one. So second one. So the second one, you understand these laws and theories and how they relate to engineering in general and in your field of mechanical engineering. You've used formula derived from these standard principles, but you've never derived them from yourself. So you've used textbook formulas, but you've not actually derived them for yourself. And then we get sort of up towards the sort of area where we would expect people to be probably going. You've got the necessary know-how. You've used these laws and theories and methodologies derived from them, such as Bernoulli's theorem, that's just meant to be an example, as part of your technical work, and you understand how they've been derived from these principles. So if you've used these theories, then you owe it to yourself to tick that box, really. It's getting you to think about the level that you're at. The next one, you're aware of the limitations of the standard scientific principles of these laws and theories and the methodology derived from them, such as Bernoulli's theorem, and you've taken these into account as part of your work. These limitations could include compressibility of fluids, effects of temperature, friction, vibration, resonance, and so on. Chances are that if you're going to be at CEng, you are going to probably be at least a level 3, level 4. The top one is probably PhD level, and is probably going to be unrealistic. You're able to understand how diverse scientific principles such as nuclear physics and material science must be considered when designing a nuclear reactor. That, by the way, is an example. Obviously you're not all designing nuclear reactors, but it's about assimilation of these principles, being able to assimilate conflicting arguments and proposing rational logical solutions. So pick the one that you think works for you. But of course, it's not quite as simple as ticking the box. You then have to say why you have ticked that box. And you're invited to offer 200 words as to your justification for the box that you've ticked. I'm not going to read that, but you get the point. It then comes on to the next one, which is about mathematics and statistical methods. And again, the same principles apply. You're aware that engineering processes are defined in mathematical formula terms, and the manipulation of the formula can provide information that helps solve an engineering problem. You won't have had to perform these kinds of mathematical operations in your career. Well, again, if you have not had to perform mathematical operations in your career, you are, I'm sorry, not a chartered engineer. But at least you found that out at this point. And sometimes the outcome of CLA is that people think, well, actually, am I really at this level? Perhaps I'm not. I know I want to be chartered, but I've never had to perform any mathematical operations in my career yet. And the realization then dawns upon them that engineers who haven't performed mathematical operations are unlikely to meet the requirement for chartered status. But most people can tick higher boxes. So you're able to substitute the correct numbers into a mathematical formula to find the value of an unknown quantity. For example, to calculate longitudinal stress in steel cross sections, knowing the force and the dimensions. I mean, some people say, well, that's A-level physics. that again ought to be something that people are doing. But sometimes we do find engineers who say, well, I'm out here, I'll take the money, whatever it is they do on Who Wants to Be a Millionaire these days. Sorry, I'm digressing. Then you can go to the third one. Substituting correct numbers into mathematical formula, interpreting the answers to calculate the value needed to solve an engineering problem, using complex mathematical concepts such as differential equations, complex numbers, series, etc. And then evaluation, developing complex mathematical modelling techniques, a detailed statistical approach to engineering processes and risk management systems, computational analysis. And then the very top one, you understand how complex mathematical concepts such as catastrophe theory. Goodness me, we're living through a catastrophic time, aren't we? Bayesian mathematics can be used to solve technical engineering problems. Again, you may not be at that level, but that's trying to make the point that this is that would be, cutting edge first principles research at PhD level, I would think. And again, you're then invited to put your 200 words as to why you chose that. But can you see where I'm coming with this? That this is getting you to think about what learning really means, because we're inviting you to think about engineering principles. We're inviting you to think about mathematical and statistical analysis. And so this goes on. I'm not going to go through this in huge detail now because of time. But conducting engineering analysis, again, you're aware of engineering principles, but you've not referred to them. You know when and where the laws of thermodynamics are used, but you may refer to them, but you have not actually applied them. Again, you have not applied the laws of thermodynamics. You've not applied engineering principles. You're not likely to be at chartered level. But then you've applied them. You've applied the laws of thermodynamics and tables derived from these laws to solve an engineering problem, but you're still unable to appreciate the limitations of these principles. So you might be at that level. And then you can derive the appropriate formula from the first principles of the laws of thermodynamics. And you've used FEA and CFD to solve technical engineering problems. And you also fully understand the limitations of these principles. And I think that is probably where most chartered engineers would sort of say, well, yes, I am using and deriving formula from these first principles at a sort of level that they're at. And then again, the peer-reviewed sort of PhD top of the tree type of analysis, which again is probably not going to apply to most people, apart from the very smart ones. And those who are probably in academia and spending a lot of time doing that, and well, not necessarily in academia, but who have perhaps done a PhD. Anyway, it then talks about integrating engineering knowledge, understanding and skills to develop a product or process or system to meet a defined need. And again, I'll just go to the top ones here. And you probably find that you are doing this. You're able to take into account factors which lead to uncertainty in the design and manufacturing process, able to consider alternative options and attribute numerical values to them, expressed in terms of, I talk a lot of time about mechanical principles, talk about mechanical principles, talk in quantitative terms about cost, about speed, about flow rates, about pressure. And then again, this one you may score higher on this one because it's kind of probably more related to your day job. You've been involved in significant engineering projects, complex design processes, several sites. You've developed the appropriate tools. You've coordinated separate distinct activities to complete budgets on time and that sort of thing. And again, your words and your little example there. And that's it. That's it. Well, that's actually half time because that is stage one. And what you then do is you submit stage one. We can also look at it for you as well. Andy, have you got stage two on the screen? I'm sorry to ask Andy, but I won't know otherwise. You're looking at the same screen.
Yeah, we can see it, Dennis.
Okay, thank you, Andy. So you pass stage one, and you then get nodded through to stage 2. And stage 2 is the detail. And it starts off with a description of your role. So obviously you're going to go to town on that. And then you're asked to write between 500 and 1,000 words, and I would suggest you go towards the top end of that, describing up to 3 examples of how you've carried out analysis of engineering or technical problems and proposed solutions, supported by sound technical engineering evidence. Now, when Dan was doing CLA, this was the only form. So we've introduced stage 1 to sort of really spell out to people what's involved in CLA, and some of them come to this conclusion that perhaps they need to go and do a degree or do some further learning, because you don't fail CLA. I mean, at the end of the day, they will say to you, we don't think you're at master's level yet, but go and do a unit in such and such a module, and we think you'll be there. So this is often a very good way, of finding out what it is that you need to do. This is where you go into detail about the projects and about the learning that you have acquired from it. Again, I'm not going to go into that. You then get asked to write another 500 to 1,000 words describing up to 3 examples of how you've integrated your engineering knowledge, understanding and skills to create and develop a product, process or system to meet a defined need. But again, focus on the learning. And you look at the detail of this answer. He talks about tolerances. He talks about pressure. He talks about laser programs and pressure, and using his knowledge to find the solution. And then you get one on non-technical. This is really so that they can sort of see where you are in terms of your rounded approach. And again, the information boxes will light up to talk about what it is that you've done, because again, although it's not testing your non-technical knowledge, CLA, it gives the assessors a bit of background as to where you actually are in the whole process. And then non-technical subjects, you've then got to put that into words. What you've ticked that box above. Why have you ticked it? What have you actually done? And then some statements on the technical nature of the training that you've done and courses. So you may have, any courses that you've already done will be taken into consideration. So if you've already done some master's modules, then this is your opportunity to do that. Sometimes people have maybe completed some part of a master's degree, but not all of it. So this section does enable you to go into detail about courses that you've done, and the assessors will take any learning that you've already done, any formal learning that you've already done, into consideration in this one. And then again, some words to justify that answer. And then a final one, which is about the nature of your technical role. I mean, do you follow standards and procedures produced by others? Or are you working for first principles outside of the current scope? You are working from first principles. You would expect to be working from first principles if you are a chartered engineer. You'll be setting the standards and the principles, not following them. But of course, this form applies to IENG as well. So it might, you don't get too hung up about whether you should be ticking the second or the third or the fourth box. You're not going to be judged on that. You're going to be judged on the case that you make. I mean, be fair to yourself, but but don't over egg it if it doesn't relate to you, because you still got to justify why you wrote it. Right, and that then is it. That is the stage 2. So I'm going to return to the slides here, if I can remember the instructions that I was given by Emma. Slides. So the next steps is what I'm going to finish off with, which is you need to submit stage 1 and be successful before being sent to stage 2 form. Once you've been approved by the stage 2 CLA process at the right level, you can then apply for CEng or IENG, whichever it is, through the IMechE standard application process. Now, what I would say to you, based on what I have said, if you believe that you are in a position to do your CLA, then just drop me an email. I think my email address is coming on soon. Denis.Healy, Healy, Denis, Denis.Healy at IMechE.org. And I will send you the forms. We don't put the forms on the website for the simple reason, as I said before, we want people to understand it. And if it was a free-for-all sort of opportunity to get, chartered without a degree, and that was what CLA was, everybody would be wanting it. And so we do want to spend time going through it. I've taken too long. I want to hand over to Dan, who's somebody who's actually done it. I'm going to advance the next slide. I hope you can bear with us for longer. I don't know how long you expected this seminar to last for. We normally sort of do it an hour and a half. I hope most of you can stay with us. I think there's 94 of you. Over to you, Dan, and it was great to meet Dan many, many years ago. A great company in Newcastle, SMD, and Dan was one of the first. And he worked really hard at it, and it is the hard way of doing it. But he got there in the end. So over to you, Dan.
Thanks, Dennis. Hi, everyone, and good afternoon. So, yeah, my name's Daniel Cunny. I work at SMD in Newcastle in the Northeast. I'm a senior engineer working in the innovation team. So we are a small team of around 12 people working in the company who have a more market view. We look at emerging technologies and products and try and develop them a bit further with clients and then bring them into SMD as a new sort of part of the business. If you are working in our sector and you've got any new technologies or ideas, feel free to contact me on LinkedIn and we can share ideas. So SMD, we're proud to be from the northeast of England, pioneers in engineering since 1971. We're world leaders in manufacture of underwater vehicles, some more on the large scale subsea trenching tractors and ROVs for the offshore wind market and telecoms. We also are the largest independent supplier of world-class ROVs for oil and gas, and we make a large investment in R&D and strategic innovation programs. So one of the areas, for example, that my team are working on is trying to convert our hydraulic ROV systems to all new full electric technology. And also we've been involved in a lot of emerging subsea mining projects as well. So I thought it might probably be quite beneficial, just given a bit of background to myself and my sort of route to chartership. I do appreciate that everyone's journey towards CEng is going to be a little bit different. Maybe referring to some of the information that Dennis presented there as I was listening to it, maybe I present someone who's in the mid-career and was quite eager to become chartered early on. And on reflection, I probably think, well, maybe although I wanted to be chartered earlier, I probably have achieved it at the right time. But I do appreciate, some people might be sitting there with a lot more experience than me. So you have to just work out, is CLA the right thing for you? You can see on the slide here, what's interesting is that I actually did attempt to apply for career learning assessment in 2015. And as Dennis reflected there, that the forms were a little bit different back then. And I genuinely think that the forms were a little bit misunderstood by both the applicants and the assessors. So at that point, I kind of looked at the feedback, and it was exactly as Dennis says. I thought, well, am I ready for CEng? And part of me thought, well, I am, and the other part of me thought, well, I've got a lot of other really, really busy things to do at work, so I'll get on with them. And then it must have been a few years later, I contacted Dennis and I know Dennis mentioned it can be a bit of a thorny subject, the idea of further learning. So it was kind of similar for me. I said to Dennis, I said, okay, tell me what I need to do. What courses do I need to do? I'll try and do some courses. I want to become CEng. And it was at that point where Dennis said, well, hang on a second, the CLA application process has been revised. And I went through that process, and uncannily, I actually turned out I had 7 years postgraduate experience at that point. So that those two things just came about by coincidence. And then I was successful through CLA, and then went on to being chartered the year after. So that worked out quite well. And just some notes on the right hand side there to say, well, at one point I thought I was eligible for CEng. But with a little bit more time and a little bit more experience, just by putting it to one side really and getting the timing right, after that I had actually led two world's first projects in offshore robotics. So of course, carrying out those projects means I'm going to deepen my knowledge and deepen my experience as well, which made me more eligible not only for CLA but then also more eligible for chartership the year after as well. So my experience of the CLA process, I think, as Dennis has said, that it is really important to separate knowledge from competence, and it's almost easier said than done. You really do need to take time on the application. Is CLA suitable for you? Does it fit with what your ambitions are with both your route to chartership and also the further learning that you can commit to, or that you have done, or that you want to do in the future? For me, it wasn't really practical for me to do an IMechE at the time. So it was sure to find out that CLA was an accessible way for me to become chartered. I would definitely try and recall some formal training that you've completed at master's level. Dennis mentioned there about reciting master's courses and modules and trying to reflect on where your knowledge and learning is against that. Try and extract and focus on the theoretical, analytical side of your job, because it is quite difficult. But you need to if you're working in especially a lot of chartered engineers are in project roles. They're in different types of roles. They're not all really analytical on a daily basis. So they need to understand what training they've done and what further learning they've done that takes them up to master's level knowledge. And my tip for that is to focus on the theoretical and analytical side of your role. I definitely think that if people have approached CLA in the past, and it was at the time when the old forms were around, if you've seen that as a bit of a barrier, then you should kind of put that to one side, I think, and reapproach it, because splitting the forms into two stages has definitely made it a lot easier for the applicants to understand what the requirements are and therefore write down what their different knowledge is. I almost think as well is that once you've gone through CLA, the application process for CEng itself seems a lot less tasking. Certainly, I think a CLA Stage 2 form is essentially very similar to some of the questions that are asked in the CEng application form. And one of the things that I thought was quite interesting was the fact that actually there's no judgment of you completing CLA at all when you come to do your chartership application. So I'm sure Dennis can maybe confirm this at the end, but I'm under the impression that when someone receives your CEng application form a year later or 6 months later, they have no real record of the fact that you went through CLA to get there. So that, I guess, one of the benefits that gives you is that if you put a lot of effort into your CLA application process, then you know that effort can be transferred into your chartership process fairly easily. Be patient and be honest of your experience and your knowledge and how the knowledge is linked to your experience. Because if you look at my example, for example, I had applied and then, a number of years later reapplied, and it was much easier for me, because the reality was that during that time I had gained deeper knowledge and got involved in projects that were much more analytical and much more academic. As you become higher level in the company that you work for, and you embrace more widespread work, then of course you're going to deepen your knowledge. another tip that I wanted to pass on as well is that I was quite lucky to have this, and maybe some don't have this, and if you see the opportunity, you should push for it. Is that you should get involved in academic industry partnership projects such as KTPs, or any sort of involvement with universities, because of course, if you're working on collaborative projects with people who are studying PhDs, then of course you're going to be deepening your knowledge and your master's level learning for your CLA application. Some other good tips as well. Dennis has already covered the bubbles on the PDF. For certain, the questions that are asked in the CLA application form are certainly more clearer when you start to click on the bubbles, so the information bubbles, and read through those as well. Another tip that I find that's very common amongst my peers that are at different stages in chartership applications with the IMechE and other institutions is that people come across barriers, that they believe there's a big barrier in front of them. It might be that they got some feedback from the IMechE on CLA stage 1, or it might be that one of their colleagues has told them, oh no, you really need to be promoted to this level before you can be a chartered engineer, or what have you. And they hear those barriers and they just put the barriers up personally themselves, and they put it away for years. And what I try to support people with that I work with at SMD is to say, just try and overcome that barrier straight away, because it likely isn't a barrier. It's just an assessment of where you are today, and you can put some further learning in or some work in to get over that. So a little bit about as well what's it like, becoming chartered. I think there's no doubt about it that becoming chartered was one of my career aims, so I'm very happy to have achieved it. But one of the interesting things is that prior to becoming CEng, I already took quite a significant part in some industry engagement anyway. So that included doing industry lectures at master's classes at Newcastle University, getting involved with STEM activities, and also doing some informal mentoring and of developing engineers within the company that I work for. I would definitely recommend that people do that. If anything, it's rewarding and it's good to engage with different people, and you learn a lot from surrounding yourself with different people, even students from universities and high schools. And I do believe it contributed to a successful CLA application form and a CEng application form. So I would definitely recommend that as something that people should get involved in. Now that I have achieved chartered status, I have seen an increased sort of formal engagement with people who I work with within SMD. For a number of years now, I've always run sort of like a steering group of people to get together to talk about how they can become chartered and how we can discuss project experience together to try and extract people's knowledge. But that was always done on an informal basis. And now that I'm chartered, I'm able to become a mentor for people on MPDS at SMD. So that's good. So now it's completed. One of the things that I do is I just try to push people to say, get on with it. It's about your personal priorities, but it's there, and a lot of people are falling in that category of BEng plus CLA to reach chartered status. So definitely, if it's one of your priorities, you should use CLA as a route towards it. That's it from me, guys. Thanks.
Thank you, Dan. That's very informative. Yeah, you did it, and you've reaped the rewards of it. And it's been a pleasure to work with you. And thank you for being here tonight. Right, I'm going to try and take any questions. I don't know whether Andy, I've got any questions on the chat or whatever. I think that you need to probably put questions on the chat because I don't think you can unmute yourselves.
Yeah, there's a couple, Dennis. I appreciate we're kind of running over a little bit, so we'll try and be quick.
Yeah.
Somebody's asked, can the further learning plan be retrospectively based on previous experience?
A further learning plan is about what you're going to do in the future. So it's learning that you haven't done yet. That's the point about it. The point is that you're not at master's level. So the answer is it's stuff that you are going to do. The retrospective is the CLA, really. I mean, that's for people who want to look back at stuff that's already done. Try and choose some things that you haven't, learnt about. I mean, maybe if you have, it's back to master's level. So it's forward-looking at stuff that you're going to do in the future and put it on the plan and get it signed off.
Okay, thanks, Dennis. Second one, just for clarity, somebody's asking, is there a CLA interview or is it just paper-based submission?
Good question. There is a possibility of an interview. The idea is it's paper-based, but if the assessors feel that they haven't got sufficient information, they may ask you for some more information, and it's possible that they may ask you for an interview. If they ask you for an interview, it's basically because they're not convinced that you've made the case, but they have seen something in you that they think might be able to demonstrate that you've got master's level learning, and that having a chat with you will sort of potentially bring it out. So try and avoid an interview by answering fully and using the word count. If you are asked specifically for more information about a particular question, then you've got an opportunity to submit some more words. And if you do get asked for an interview, then obviously be open-minded about it, try and understand the areas that they want to discuss with you, because they are giving you an opportunity to sort of make the case. But as I said before, there isn't a fail. I mean, if you're not at master's level, then you can still get to master's level, and CLA assessors will give you the advice that you need to do what it is you need to do to get there.
Okay, thanks, Dennis. There's a couple of people asking questions which are quite specific to their particular circumstances, so I suggest we'll reply to them individually after the webinar. Somebody's asking, is the CLA recognised internationally? I'm assuming that means can they use that to go elsewhere, I guess, for accreditation?
Well, in the sense that IMechE is an international organisation and people in international markets are doing CLA, yes. So CLA is available to people overseas. But the point is this: CLA is not IMechE membership. CLA is just demonstrating that you've met the academic requirement. So CLA as a concept isn't understood anywhere really outside the IMechE. It's IMechE's way of enabling people to demonstrate master's level knowledge. The thing that's internationally recognised, of course, is CEng. So that's the international recognition. And if you've not got a master's degree and you want to get chartered, then CLA is what you'll need to do to get there. And the question is about, can overseas people use CLA? The answer is absolutely yes, and they do. Hope that answers that.
Excellent. Okay. That does, Dennis. There's one final question, which is on a slightly different subject. I think due to the slides at the start of your presentation. Somebody's asking, do many members transfer from IENG status to fellow?
Well, yeah, interesting question. And I'm not sure whether the questioner means sort of, do they transfer from IENG to fellow via CEng? But it is possible to be a fellow of the institution and not be chartered. It is possible for somebody with IENG who says, well, actually, I think I'm at fellow level. I don't really want to do CLA. I don't really want to do CEng. But I'd like to be a fellow, because actually, if I can say I'm a fellow, that's got more cachet than saying I'm a chartered engineer. So there is a designation called IENG, FIMechE, IENG Fellow of the Institution of Mechanical Engineers. I have to say, there are not many of them. I think there's literally about less than a dozen, I think. and in fact, we even have one or two IMechE fellows, IMechE IMechE. So the answer to the question is yes, it is possible for somebody who is IENG, if they can demonstrate the fellow requirements, to achieve fellowship without actually achieving CEng, and therefore not having to bother with CLA. And I do know one person in particular who said to me, well, actually, if I can say I'm a fellow, people won't be saying, well, are you chartered or are you incorporated? They'll just say, oh, you're a fellow. So I'll take that. So yeah, go for it if that's what you'd like to do. I mean,
okay, I'll do one.
Sorry.
I'll do one final question, Dennis, and we'll bring it to a close. Do you have a rough idea how many engineers pass the kind of CLA assessment each year?
It's a good question. It's in the low hundreds. You know, most people don't do CLA. I don't know off the top of my head what that figure is, but I'd be very surprised if it's much more than 100 or so each year who go down this route. But nevertheless, that's 100 people a year who you know wouldn't have got chartered otherwise. And you know it's an option that is there for people. It's not there for everybody, and it's not going to work for everybody. But you know there is a minority of people who think, well, yeah, I want to do the CLA route. It is a route to chartership. It's a fairly select band of people who go through that every year. It's a fairly small number, but it's well worth doing. But it's not a big number in comparison to the thousands of people who get chartered every year.
Okay, that's great. I think we'll bring things to a close. Thank you very much for that, Dennis. It was really great to hear from Daniel.
If anybody does want any questions answering, just my email address again, because it's not on this slide, is Denis, Denis.Healy, Healy, @IMechE.org. And if there are more specific questions, then please feel free to send that to me. And of course, I've got colleagues all over the country, and we are doing, you know, we want to help you wherever you are. I know this is a North East region event, but the nature of it all now is that people are logging in from all over the world, not just in the Newcastle and Teesside area. So thank you very much for that, and thank you very much for having me.
Yeah, so anyone who sent a question through that we've not answered, we've made a note of those, and we'll get back in touch with you later this week via Dennis. So thanks very much to Daniel, thanks very much to Dennis. Thanks for joining us, and hope everyone has a good evening. Thank you.
Thank you.
Thanks.